And last but not least, I'm incredibly excited for what another team in the Polkadot ecosystem is trying to bring forward in the coming months. Hyperbridge is a cryptoeconomic coprocessor poised to provide the first secure bridges to and between many other blockchains out there.
I'm the founder of Polkadot Labs, and we're building a decentralized trustless bridge called Hyperbridge. Hyperbridge is a coprocessor for secure interoperability. Fundamentally, if you want secure interoperability, you want secure messaging, you also need to confirm the source of these messages, right? You need to authenticate the source of these messages. The blockchains that are the origins of these messages, they do produce cryptographic proofs that you could potentially use theoretically to confirm the validity of messages by verifying signatures from the validator set, the supermajority of the set. This would be your consensus proof, and that would finalize some state commitment or state root, if for those of us who are maybe technical. And then you could then verify state proofs of messages that are in the state, or you can think of it about in the outbox of the blockchain. And then you could now confirm that some messages are indeed coming from a blockchain. But the problem is that all of these proofs that I've just described are very expensive to verify, especially if you're maybe on a constrained blockchain like the EVM. Then this would cost millions and millions of gas, and that's why no one does this, right? And so what we've done is we've figured out a way to still verify these proofs, but then produce a much cheaper proof that can be verified on these EVM chains that can then attest to the validity of cross-chain messages. So Hyperbridge is this co-processor, and what it does is it's going to aggregate all the messages coming from multiple chains into a single proof, so that any chain can then receive all the messages that they care about using a very short proof. I would say Hyperbridge is already very similar to Polkadot itself, in the way that it facilitates interoperability between parachains. I would describe Polkadot as this very strict father, he has his rules, and Hyperbridge, you could think of it as a very chill uncle. It doesn't have as much of a strict rule set. And so what this means is that on Polkadot, parachains essentially have to give up their consensus. They have to give up their sovereign fork choice rule and follow Polkadot's consensus in order so that it can be bridged. But in Hyperbridge, we don't enforce this, right? We allow you have your own consensus model. As long as we are able to track this consensus, then we can facilitate bridging, across all the networks that we're connected to. I think it will make Hyperbridge more efficient in the way that it's able to allocate the computation that's needed for proof verification. It will also allow it to scale up and scale down, things like elastic scaling, where we might see intermittent load from source chains making a lot of messages to a destination chain, or we might see times where there's just not a lot of messages and we can easily scale down our compute resources. I think Parity and the Web3 Foundation, they're building stuff that will allow parachains to dynamically scale their parachains. It's the case that all of the interoperability solutions that exist on the market today are all intermediary solutions. They are solutions that essentially involve a third party who will then take the state of one chain and attest to it on another blockchain. This sort of architecture has been very, very expensive for the crypto ecosystem. I think there's now been over $2 billion of assets lost to bridges. And this is a third, actually, of all the size of all crypto hacks. So I think the total size of money that's been exploited in DeFi protocols is around 6 billion. And so bridges constitute a third of all these exploits. So this is a really huge problem in the industry, and architectures that put security first have the potential to solve this permanently. And that's what we hope to achieve, right? We hope that more and more people can then be onboarded and can feel safe using bridges. More and more protocols can now start to build cross-chain applications and not worry about the security of the underlying bridge. And of course, they can start to express more and more complex applications that require lots of liquidity. Our goal is to focus on, I call them liquidity hubs, where are people currently using DeFi protocols, and there's a lot of DeFi liquidity locked up. And of course, these people, they need secure bridging across these different hubs. You can think of it like a direct flight from Tokyo to New York, that sort of stuff. That's what Hyperbridge will be aiming to provide. But of course, we can support as many chains as possible. In fact, our architecture on Polkadot is what enables this hyperscalability of Hyperbridge. Hyperbridge has the potential to solve liquidity fragmentation. It's the case that because token issuers don't trust bridges, they very then often have to roll their own. I give an example here with USDC. USDC, the issuer Circle, essentially had to roll their own bridge called CCIP, which may not be very secure as well, because they still have an intermediary who does this bridging. But you might argue that maybe this isn't a problem because they're already a centralized token issuer themselves. But imagine teams that may not have the ability to roll their own bridge, being faced with trying to pick a bridge on the market that's maybe not secure. Actually, what we've seen is that teams, what they would do is they would combine two different bridges or more as a source of truth for cross-chain messages. Of course, this is very inefficient and very expensive. Hyperbridge has the ability to come in and essentially make this cheap. I think that we have all of the resources to onboard as many users as possible. It's just the case that there are things like wallets that are needed that might be a hurdle. There's also, I guess, things like finality issues for maybe blockchains that are not as fast as Polkadot, and they might face these issues. But ultimately, these are issues that can be solved. The most pressing issue was the fact that we didn't used to have all these different blockchains. We didn't used to have all this block space, but now they're available, and now developers can now start to build really, really cool stuff with this. With stuff like elastic scaling, you can have a blockchain that actually has like 1 second block times. This can give users very fast confirmations for whatever it is that they're doing. You could have people build games that are real time. In fact, we just recently saw a community member in Polkadot build the game of life simulation on a blockchain, and it's able to run in real time just by having faster block time. So I would say that the infrastructure is already there, and that we just need to do more business development. We just need to do more developer onboarding so that they can start to build these really cool applications. Gav's paper, I will never forget this. I was completely mind blown because he was basically saying that blockchains are essentially computers, and the idea that a single computer will serve the whole world is a very misguided one. I mean, now look at, there's a computer everywhere. There's computers, in the traffic signs. There's computers in our doors. There's computers in our phones. So I think it's the same thing with blockchains. They're just computing platforms. And as a civilization, our compute needs has grown massively, and they will only continue to grow. It's unlikely that any single chain, any single stack will be able to serve the sheer scale of all of these compute needs. And so we would need a multi-chain framework, right? We would need a multi-chain future. But then the problem becomes very quickly, how does this different computers coordinate, right? Imagine if your phone could not be connected to the computer on your door. That would suck, right? And that would be very pointless because it just make the UX so much easier. You just walk to your door, they communicate, and then the door automatically unlocks. But if they couldn't communicate, then you couldn't have these kinds of applications, right? And so for us, we see that the application space, this broad sense of the word, the application space for applications on a single L1 is very limited versus the application space for multi-chain applications that can leverage things across different ecosystems, across the different functionalities that these different virtual machines provide, EVM, WASM, RISC-V, whatever the case may be. Being able to then harness all of these different things and bring them all together will create definitely more applications for everyone to use. So bridges enable this. And it's very hard to see a world where bridges are not even the landing point for new users in crypto. And I might use Google here as an example. You can think of Google as a bridge for users to the internet because Google kind of aggregates the entire internet, presents them nicely. Bridges will also do the same for crypto. We don't want Hyperbridge to change very much. What was very important for us was to set the foundations for how it would scale into the future, and just let that be what it becomes, right? So the problem with bridges and the problem with these things that are supposed to be aggregators is that if a lot of people are relying on them and it changes very often, then it cannot be that shared point, right? It has to be very stable so that people can then come to rely on it. So for us, all of the changes left to build on Hyperbridge will just be very minor stuff, making our proofs cheaper, supporting more and more chains. There will be nothing disruptive at the Hyperbridge layer. Maybe changing our messaging protocol. We're never going to actually change our messaging protocol. And in fact, there's one other protocol that famously hasn't been upgraded. It's called Qmail. It made its first release back, I think, in the 80s, and it's still the same. It's still the same piece of software till today. So I want Hyperbridge to feel something like Qmail, right? It just works, and the only time it changes is if it adds more and more chains. Agile core time allows Hyperbridge to be able to scale horizontally, right? So we can purchase core time on demand for new cores that need to process new messages. Things like elastic scaling can allow our cores to scale up when there's high demand and scale down when there's not a lot of demand. So these two things, I think, will be very instrumental to Hyperbridge's success. We are already doing very well in the, Polkadot version 1. Paradigm, we haven't really had time to think about what the Jam future brings, but it's either one of two, right? We continue with the parachain service, but if we see that some things that Jam enables makes our lives so much easier, then we will, of course, move things over to a more Jam native architecture. But at the moment, we'll probably just stick with Polkadot 1.0. And I also think it's we need to use what we have at the moment before we then start to demand new stuff, right? We have to reach these limits that Jam will then make easier for us. I think that, and this is actually the reason why I got Web3 pilled, like they say on the internet. For me, when I really understood blockchains, I saw that the killer application for blockchains was actually governance. I live in Nigeria, where we may be famous for the most corrupt government in the world. And for me, I see blockchains as a way to combat this sort of corruption, where you have enforceable code and enforceable agreements that if they're not met, then some things just don't happen, right? And then there's also on-chain reputation, where sure, maybe people forget, maybe people have short-term memory, but the blockchain doesn't. It keeps everything. So these things combined could allow for a more decentralized and a more bottom-up form of governance, where people are actually making decisions on chain about how things should change. I think that blockchains, in their final form, would actually be the substrates, kind of how Gavin Wood called it, for human coordination. We're already experimenting with this with OpenGov. I think it's a great experiment. I think a lot of the stuff that will make OpenGov a success will also make blockchain governance in general a success, and can be make it adopted by people of the world. I think that there's some excesses that need to be curtailed, maybe rather aggressively, because when you're not aggressive, people tend to see how much they can get out of you. So I'm not advocating for some sort of authoritarian measures here, but we could definitely do less irrational spending and do more well thought out, well budgeted spending. I think for instance, the Treasury doesn't have a budget, so that might be an issue, and maybe the first step would be to agree on what the reasonable yearly budget might be, right? This is, and the more and more we do these things, the more and more we become like a government, right? Because that's what a government does. The first thing it says is, okay, here's our budget, these are the things we want to spend on, and they try not to go out of that budget. And that's kind of what we would also have to do in OpenGov. I think the problem that we're still, that's still unsolved is, how do we prevent the people who have a lot of tokens or a lot of assets from optimizing for the short term at the expense of the long term, right? Because, these people, they have a lot of money. They might want to optimize for the short term so they get more money and then leave. whereas the rest of us are left holding the bag, right? And that's usually what happens even in the real world. So these are open questions, I think, and these are, I think, mechanistic questions or relating to do with game theory, that there will need to be more research around how to combat these sorts of people. I would say something along the lines that it might become inevitable that companies themselves become DAOs. There's this large move to tokenize, for instance, stocks. And at that point, it's like, okay, everyone who has a stock is already kind of an entitled voter on what should be the direction of a company, right? They vote, should we give Elon Musk this $70 billion raise, and they, then they could, this process could then become more blockchain native, where in fact they're voting about which products they want to release, right? And shareholders who are token holders can also have a say in the direction of the company. And at that point, you now have a DAO, essentially. You have a DAO of people who are coordinating over a product, and this DAO is even more permissionless because it's on-chain and it's not restricted to maybe accredited investors on Wall Street, but literally anyone anywhere in the world can be a part of something that they care about, and can also influence the direction of this thing. And like I said, I think that this is all part of this greater move towards decentralization. I think that the blockchain movement is a sort of frustration that's kind of built up over the years with the elites running things. And in this information age where everything actually is now governed by computers, takes essentially the substrate, the computers, and then makes them kind of work for us, right? And makes them the thing that enforces contracts between people. It's interesting, I think, that we got here just by combining a lot of these different things, combining computers, combining the internet, combining, cryptoeconomic systems, combining a little bit of cryptography, and then using that to rewrite the structure of society and say, well, power doesn't have to flow from the top. Everyone's voices can be heard, and everyone can actually participate. Time I'm actually talking about the whole thing. So a hyperscalable coprocessor for cryptographically secure interoperability. None of these words are in the Bible. Let's go back to the simple verification protocol. What Satoshi is proposing here is a blockchain as a verifiable computer.